Good morning all. Today we will solve a numerical question on image size determination and its transmission. So in this question, the packet configuration it is given to us. It consists of 14 start bit, 8 bit of information and 14 stop bit. In the next part, information related to digital image it is given to us. We need to transmit 200 images where in each image the number of rows it is 1280, number of column it is 960, and this digital image it consists of 256 number of intensity levels. If this much amount of data, if this much amount of information we have to transmit using this packet configuration, and my transmission speed it is 3 M baud, that is 3 into 10 to the power 6 bit per second, then what would be my transmission time that we have to determine. In the next part, if my transmission speed it is 30 gigabaud, that is 30 into 10 to the power 9 bit per second, what would be my transmission time that we have to determine. So let us solve this question. So in this question, let M represent the number of rows. So in this question, number of rows for a given digital input image, it is given to us, it is 1280, and represent the number of columns. So in this question, number of column for a given digital input image, it is given to us, it is 960. So total number of pixels. So total number of pixels in a given digital input image, in one digital image, it is nothing but equals to number of rows multiplied with number of column. Since in our digital image, number of rows it is 1280, number of column it is 960. So total number of pixel it is 1280 multiplied with 960. If we simplify this, we will get the total number of pixels in one digital image, and it is evaluated to be 1228800 pixels. Next, we need to determine the bit depth, and in the question it is given to us that digital image it consists of 256 intensity levels. So these 256 intensity levels, their representation in digital image, it start with the minimum gray level 0 to the maximum gray level 255. In order to determine the bit depth, we will represent this number 255. We will represent this decimal number 255 into its binary format. So this decimal number 255, we will represent it into binary format. The binary representation of this decimal number 255, it is 11111111. Total number of bits required to represent this decimal number 255 into its binary representation, it is equals to 8. 1 2 3 4 5 6 7 8, and hence the bit depth, that is k, it is equals to 8, which represent each pixel uses 8 bits. Each pixel uses 8 bits, and in a digital image we have 1228800 number of pixels, and each pixel uses 8 bits. So size of a digital image, or in other words, total number of bits in one digital image it is equals to this many number of pixels in one digital image, and each pixels uses 8 bits. So total number of bits in one digital image, it is total number of pixels multiplied with number of bits used by each pixels, that is 8. So if you simplify this, you will get total number of bits in a given digital input image, and it is evaluated to be 9830400 bits. So this is the size of a single digital input image, and we have to transmit, and we have 200 such digital image. So total number of bits considering all 200 images, it is equals to, this is the size of a single image, and we have 200 such images. So total number of bits considering all 200 images, it is equals to size of a single image multiplied by 200. So if you simplify this, you will get the total number of information bits, and it is equals to 1966080000. So this is the total information bits that we have to transmit in the form of packets. The packet configuration, which is given to us it consists of 14 start bits, 8 information bits, and 14 stop bits. So we have to transmit these many information bits in the form of packets, and since in each packet it consists of only 8 number of information bits, so first we need to determine the total number of packets. So number of packets, it is equals to the total number of information bits. So earlier we have determined the total number of information bits as 1966080000. This many number of information bits considering all 200 images, and in each packet it consists of only 8 information bits. So total number of packets, it is equals to total information bits divided by number of information bit in each packet. So if you simplify this, we will get total number of packets as 245760000. So this many number of packets that we have to transmit, and in each packet it consists of 14 start bit, 8 information bit, and 14 stop bits. So total number of bits in each packet, it consists of 14 start bits, 8 information bits, and 14 stop bits. So total number of bits in each packet, it is 14 plus 8 plus 14. If we simplify this, that is each packet is consist of 36 number of bits. We have determined this many number of packets, and each packet it consists of 36 number of bits. So total number of bits that we have to transmit in the form of packets, it is equals to number of packet, that is 245760000 number of packets, and each packet it consists of 36 number of bits. So total number of bits that we have to transmit, it is number of packets multiplied by number of bit in each packet. So if we simplify this, we will get 8847360000. So these many number of bits we have to transmit. So these many number of bits we have to transmit. So there are two case studies. First case studies, if my transmission speed it is 3 baud, that is equals to 3 into 10 to the power 6 bit per second. We have, for this case studies, we have to determine the transmission time. So when my speed is 3 into 10 to the power 6 bit per second, we have to compute the transmission time. So transmission time, it is equals to number of bits, total number of bits that we have to transmit, that is 8847360000. This many number of bits that we have to transmit divided by the speed, that is 3 into 10 to the power 6. If we simplify this, we will get the transmission time, it is equals to 2949.12 second. In the second case studies, if my transmission speed it is 30 gigabaud, that is 30 into 10 to the power 9 bit per second, what would be my transmission time? So in the second case studies, my speed is 30 into 10 to the power 9 bit per second, and for this speed we have to compute the transmission time. So again, transmission time, it is equals to the total number of bits that we have to transmit, it is 8847360000 divided by the speed, and in this case my speed is 30 into 10 to the power 9 bit per second. If you simplify this, we will get the transmission time, it is 0.2949 second. So for this given question, we have determined the total number of information bits. We have also determined the total number of transmitted bit as per the given packet configuration, and finally we have determined the transmission time also. And with this question is over. Thank you all.